Ladies and gentlemen, I hope you've had a lovely lunch and refreshed and ready to go. So, panel 3, the role of innovation in water distribution. How does wholesome, clean water arrive at your taps? I would like to invite to the stage Matjaž, Berčon, Director of Komunala Kranj, Slovenia. Gonzalo, Meschengieser, CEO of Argentina Chamber of Water. Welcome again. Henrique Gustavo de Costa, Director of Smart Water Solutions and Business Unit. And all the way from Brazil, Weslley H.A. Barbosa, Coordinator, Smart Water at Igua, Saneamento, Brazil. And I am Milin Patel, your moderator. So, gentlemen, just reading the titles here. Smart Water. I was at home with my son while I was putting things together. I like to be prepared. And he goes to me, "Daddy, what are you doing?" And I said, "I'm researching smart water and the Internet of Things of water." And he said to me, "Dad, how can water be smart?" And I paused. For a youngster, he's only 8, to ask me that, how can water be smart? So I thought, this question I would love to ask you gentlemen, because I understand you are very smart with water and you deliver to millions of, as a combined effort, to millions of people in a smart way. So, could I pass the mic to you first?
Okay. Good afternoon, ladies and gentlemen. My name is Matjaž. Okay, first informal question before the presentation. I will answer in that way. Water is smarter than we are. Why? In Slovenia we have a proverb. Slovenians knows it. The water finds way out where we cannot.
I like that. And over to you, Gonzalo.
Well, what my colleague said is a problem for water utilities because we have which we call leakage of water loss. Is the amount of water that we lost during the pathway from the plant in which the drinking water is produced to the consumer. In Latin America, we have an average of 40% of water loss. So the water is smart, but the company is not. That is the problem, okay? Thank you.
Yes, good afternoon. So, saying about smart water, I think that the water utilities are very embedded on the smart cities subjects. And more we have technology to monitor the water, like the leakage, the pressure, the consumption. So all these informations together, we can become, let's say, a smart utility that you can monitor. And the interesting point of the water is that through the consumption of water, you can know better the behaviors and the profile of your end customer, or how we're going to use this. We use more in the morning, in the night, for showers, for clean, whatever it is. So be smart in water is get more informations that in past years we were a little bit blind, isn't it, about the consumptions and all the informations in the water network. And with now the Internet of Things, all these kind of communications, we are much more smarter how to manage the water.
Fantastic. And over to you, Weslley, please.
Good afternoon, everyone. It's a pleasure to be here with you. Thank you, Milin. Well, smart water, as Henrique mentioned, is this movement because the water utility, they were a traditional industry for a long, long time, there were no such use of such technologies as Henrique mentioned to monitor pressure, monitor. So this is let's say, a new movement. You use IoT sensors, software, AI, analytics to improve the quality of our operations. So we have a very difficult challenge that is to locate invisible leaks, because all the networks of our water distribution system is under the ground. So how do you find a leak that's leaking for days and the water is not going to the surface? So Smart Water is using all this available technology of monitoring, system analytics to improve the quality of our operations, to detect leaks early, to improve the quality of our pumping systems and improve the energy efficiency of our systems, to improve the consumer, the user experience, and how they perceive the water. So smart metering is a trend to inform our customers how they're using water, and their benchmarkings, how if they can save water and improve and engage them in being more conscious about their consumptions. We need to save the natural resource, which is water, of course. So Smart Water is the combination of all those technologies to implement and improve the quality of our operations.
Thank you, Weslley. So to the audience, do you understand Smart Water now and what this means in regards to measuring water that comes out of your tap to secure better supplies? From last year, Matjaž, I tried the water at Communal Kranj out of the main fountain, and this really stuck with me, like the taste of the water. I'm used to chlorinated water out of the tap, and I was completely surprised. Could you tell us a bit more about how you can create such great drinking water with the technologies and all the other implementations that you put in place?
Okay, in the meantime, when the technician will plug in my presentation, I can say that we have really, really good sources, more or less mountain sources. But let me present our water utility, Komunala Kranj. Today I prepared just a short presentation focused on some smart solutions for water metering. Can we go forward with that? Sorry. So, it is not from today. Our tradition is pretty old. So the modern concept of water supply in Kranj was designed 120 years ago. And it is symbolized with this water tower in the center of the town. It used to be outside the town, but today Kranj is much bigger than it used to be. But the first picture we found, it is from 16th century, and just below the town center, at the river, was the first pumping station, Wassertouren, in 16th century. But it can existed already before. It is first picture. So today, the network in Kranj is more than 700 kilometers, and we supply more than 100,000 customers. We have installed 20,000 smart water meters, different producers, suppliers, but we communicate with them more or less via radio waves, M-Bus or LoRaWAN. 1/3 of those smart water meters are already combined. So we don't check water meters manually. In Ljubljana, the capital, still, in many parts in Slovenia, still the responsible person are coming twice per year in your home, and they are opening your door, they are opening your cellars, etc. So more than 10 years, everything in our let's say, in Kranj and surrounding, is communicating without this direct communication with customers. How does it look like? On one hand, we have cars, drivers, and radio stations. But what is our future? On the other hand, we have a LoRaWAN network, wireless, emission-free, and almost without human factor. And as I said, it is a future of our net water metering. At that moment, we have covered approximately 1/3 of our customers. As said, last year, Bled Water Festival awarded us with this Bled Water Festival certificate for the quality of water, also on the public spaces, because they focused on this segment, and we are very proud that we drink one of the most quality waters in Slovenia. And welcome, maybe next year again in Kranj.
Brilliant. So I guess with water distribution innovation and your role, Gonzalo, in, correct me if I'm wrong, you were pretty heavily involved in sort of water testing during the COVID-19 pandemic. Could you please share the styles of innovation that allowed you to monitor the water, but then also public health with wastewaters and clean waters? If you could give us an overview of that style of innovation and what that means for the future now.
Okay. Well, let me tell you, Milin, that we can divide into two parts. In one side, we have the water quality technologies, and in the other side, the distribution delivering technologies. In the first place, I want to remark the fact that water utility during the outbreak of the COVID-19 pandemic had the capacity to develop methodologies to detect the SARS-CoV-2 virus in wastewater treatment, and it contributes a lot with the healthcare system, not only in a local basis, but in a nation basis as well. For Argentina at least, and for Brazil and Latin American countries, it was a kind of turning point, because from that moment, every single company started trying to detect new contaminant pollutants in water using new reactions, chemical reactions, and that is one of the cutting-edge technologies proved in the field. On the other side, regarding to the distribution of water and going back to the leakage and water loss issue, which is one of the most challenging things in water sector, during the last 3 or 4 years, companies started applying satellite images to detect leakage and water loss, and it was a very useful tool to overcome this challenge. In the region, we have 2 satellites in orbit, and they work very well. So it helped a lot to avoid leakage. The other technology that was applied successfully was machine learning and artificial intelligence, which allows us to regulate the pumping of water during nights when the demand going low. And we started using bots as well, robots which are able to inspect the water in the underground, inside the pipes. Boats are as a kind of drones which goes along into the pipes and are able to detect leakage, and in some cases repair it itself at the very moment and on time. So I think we need to innovate more and for achieve that goal, we need more investment, and this is one of the challenge for water utilities for the decade to come, to convince owners, stakeholders, government to invest more money to develop new technologies. Thank you.
Another just quick question for you, Gonzalo.
Sorry.
With these technologies that were implemented during the COVID-19 pandemic and moving forward, does that data now help with public health of communities where you are testing, say, the wastewater? And has that provided more of a better understanding of actual community health? Because, everything that we do digest does come out. And if you could just share the experiences of what we can learn from wastewater with new technologies.
Well, there is a new concept called epidemiological surveillance as an early warning. So there is available some technologies that can prevent us to deal with a new outbreak of an epidemic or pandemic. For instance, if you have a pipe network concentrated close to a hospital, you can use REN molecular biology technologies to detect this presence in wastewater and to give an alert to the healthcare authorities. PCR is the technology widespread in not only in healthcare system but in water utilities. So I think the next steps is to teach the PCR system to improve their performance, detecting new microorganisms, and of course developing new reactions, chemical reactions that can tell us when a new pollutant is surrounding a sector. I think this is the cutting-edge technology regarding to surveillance in wastewater, and we hope it can help healthcare authorities in the years to come.
So definitely the advancements in technology and monitoring, we can learn so much from the waste that we secrete into the wastewater plants to measure and monitor and react a lot quicker. Yeah. Okay, it's fascinating. There's a lot to be discovered in our waste that we are just exploring now. Just before we get over to you, Henrique, I just wanted to ask Weslley. I believe in the Rio de Janeiro area, you are delivering to nearly 1.2 million people wastewater and clean water services. Could you give the audience an overview of how that is implemented with such a large-scale distribution network?
Thank you, Milin. Well, Rio de Janeiro is one of the main challenges for us because we are always concerned about sustaining a high standard of water quality, water supply, and minimizing water losses. And all those challenges are interconnected somehow. If you have lack of water supply and poor quality, they may be related to leaks in the network. And network bursts are sometimes related to maneuvers and poor pressure management. Rio de Janeiro we have even a small area, let's say, but a huge concentration of people, 1.2 million people in only 62,000 water connections. There are a lot of residential building, condos, and etc. So to address all these issues, we developed an initiative called Smart Water, which has 4 pillars: digitalize the water treatment, the water distribution and network management, energy efficiency, and smart metering. And Rio de Janeiro, we implemented almost the same number as Matjaž mentioned before. We have 10,000 smart meters deployed, which monitors about 60% of our water consumed in Rio de Janeiro. And we installed hundreds of IoT sensors to monitor pressure, monitor reservoir levels, monitor flows, operating remote valves operating the systems, and IoT sensors inclusively to monitor the pumps that we have. And all those sensors go up in one platform that we can see all the system of the Rio de Janeiro. In Rio de Janeiro, additionally, we have another issues, another challenges that are our relationship with the most vulnerable population, the communities. There are some areas in Rio de Janeiro that we have security problems, areas we cannot reach them easily. So implementing networks and sewage systems, and then is a huge concern, a huge challenge for us. But Rio de Janeiro, after 2 years of operation, has showed significant improvements in terms of water distribution and losses reduction, even in increasing in revenue because of the smart metering program and the replacement of old meters they have. So thank you, Milin.
Thank you for that. So I think the next question for you, Henrique, is that we've learned from 3 operators that are running very large-scale water distribution and wastewater. With this understanding of what the problems are in regards to the water networks, the pressure in the pipeworks, the leakages, the smart watering, revenued waters. As a technology vendor, you listen to this. How do you then get the correct style of technology implemented? And if you could just let the audience know how you would navigate this to bring the right solution to your clients.
Yeah, absolutely. I think that now what we are facing in different segments of the world is not one company that will provide the full stack of the technology for them. Now it's a big ecosystem. If we say about, for example, the meters that Weslley and Berčon said, they are the boundaries between the water utility and the end customer. So you can, with the meters, make the basic thing, it's like a bill to the customer, how much is the consumption of this end customer. But now with the use of the technology, you have much more information from the customer side, because you can have hourly data. So you could imagine someone in the traditional metering, the mechanical meters in the past, that has a leakage in their house. Sometimes the water utility will just be realized about this leakage when the customer goes to you to start a complaint. And this complaint is basically after minimum 30 days after, or 40, 50, 60 days. So, and then there is a big dispute between the water utility and the customer. It's too high, my bill, and I will not pay for this. And then you said, yes, but this is your problem because it's a leakage inside your house. So with this technology, we can avoid this because you can have daily data and you have alarms for this. And you're going to say, okay, Henrique, so every day someone will read the meters in these houses? No, we have different technologies. I don't know if the people from the technical could display here one of my slides, please. We have now, all over the world, different kinds of technologies to take the data from the meters, to read the meters. Also, one of these technologies are also considering that the telco operators, so Movistar, Vodafone, these kind of companies that provide us the service of the mobile service, they can also read the meters for us, because the meters has this kind of technology to get the information daily, hourly, whatever we set up for this. And we have different kinds of technology, and I'm very happy when I see here Kranj. I am a citizen of Kranj now. I live in Kranj for 2 years, and when I arrived, I was quite surprised how advanced the water utility in Kranj was, because I will show you some numbers here. There are a huge investment all over the world to replace the mechanical meters to the smart meters. Like I said, with different technologies of reading, depends on the topography, depends on the costs also locally. So there is no best technology or worst technology, but remote technology, it's basically the best. And just for you to have an idea, the growth of this market, it's about 6% every year. The total amount of meters, let's say, installed every year in the world, it's about 135 million meters. So could you imagine, this is a huge number if you increase this replacement 5% every year. And the numbers that we are saying is that in these years, 22, 23, the investment on new meters was about 5 billion euros. And now we are saying about in the next years will be about $9 billion. So it's a huge investment that everybody is doing in this new technology. If you go for the next slide, please, you're going to see that that's why I was very surprised, because Komunala Kranj was very advanced against, let's say, big utilities all over the world. You can see here a lot of announcements. For example, Pitpa in Belgium, they are replacing 2.8 million meters. Now they started this change, you know. All over the world, you can see there are new bids, new investment. EU is financing a lot some countries to recover after COVID. For example, Italy will receive 1.7 billion euros for meter replacement. Spain will receive about 3 billion euros for replace the meters, the actual meters, for smart meters. And for the technology point of view, what we are trying to develop in the top of just metering and read the data of this consumption, it's another sensors. We could adapt another sensors into the meter, like pressure sensor. It's very important. If you don't have pressure to reach this house, how are you going to supply this house? Water quality, it's a big challenge because most of the technologies of water quality, they have a big energy consumption, and you need to make some maintenance on field. So we are working, not only we, but all the ecosystem of the suppliers are working hard with the new technologies in the hardware, with new sensors to identify in front of the house of the utility customers the pressure, the water quality, the consumption, and other applications, but also very important, like Gonzalo said, in the software side, you know, because what we're going to do with all these informations that we got from water and how we can interface this demand with the water production in the treatment plants. So this is the big challenge, and we are embedded on this AI, machine learning, telco operators ecosystem. So water utilities are embedded on this, and we are trying as a technology provider to find a way to get the most advanced technology in the world to manage the water.
Fantastic. I'm already feeling really smart with what's happening with the water here. It all sounds really fantastic that we're able to monitor, measure, use AI, and some of the figures that you've put up, I was astonished at the investment and the rapid growth. But with such quick adoption, there must be some negative impacts that have occurred. And I would like to go through each panel of just something where you've tried to mobilize something, where something may have not gone right, and the way that you fixed it, because I'm looking at potential high initial costs, complex implementation, mobilization, engaging with the end users. I would, if you could just share just the way that you've understood this and acted so it's a win-win for all, because there's always got to be some sort of downside to such great smart work that's been deployed. So over to you, Matt.
We are talking about costs.
Yeah, just experiences of...
Yeah. We 5 years ago, we started with this... no, actually, we started 10, 15 years ago with MBUS, but with LoRaWAN technology, so wireless, emission-free, almost without a human factor, as I presented before. one of our aims was also that it shouldn't be more expensive than it is. And I think we are very nearly. So on this basic level, from a utility company perspective, so when we have to buy new smart meters, smart meter is the same price like classic meters. Only, how to say, but you need to have some infrastructure support. Normally, we found this support in Iskraemeco. We are very close, 1 kilometer away. So at the end of the day, it is not more expensive. We are now talking about impressive numbers, but probably in all those surroundings, they are starting from, I don't know, lower starting point. So we started on a certain level. Yeah, I'm proud that we are maybe one of most, not maybe, that we are one of most developed utility companies in Slovenia. So thank you also, Henrique, for awarding us with such a compliments before. So for us, it wasn't a special financial issue, more or less technical, more or less issue related with education of our staff, etc. So we put much more effort in staff, in education than. So the financing is only, let's say, a coincidence then.
For yourself, Gonzalo, equity and accessibility. The poor may not be able to receive waters in this way, in the smart metered way, but is there ways that you've overcome this so it's very equitable for all to receive smart watered meters and the technologies that we've been discussing so far?
Do you know the meaning of 0 day?
Please explain.
0 day.
No. Oh, day zero.
Day zero.
Yes, sorry. Yes, day zero, yeah.
Unfortunately, we suffered the day zero in Sao Paulo in 2014, then in Montevideo last year, and if nothing changed, in Mexico in 20 days, they are lacking of water. They are running out of water. So governments, utilities, and consumers are aware of this situation and trying to solve the problem of accessibility, not only in urban areas, but in slum, informal settlements as well. Climate change is affecting more in informal settlements than in big cities. So I think there is an awareness about this topic. The thing is that investment can be put not only in the final consumer, but in the management of water utility as well. So the priority is too difficult to be defined by stakeholders nowadays. For instance, in Sao Paulo, after the 0 day, please correct me, Henrique or Weslley, that you are local there. After this crisis, the water utility developed a kind of technology called DMAs, which is split the pipelines into phases, into sectors. So if you run out of water in one manancial, in the case of Brazil, they can take water from other system, which is called cantareira. So they keep the reversal of the water distribution. This is the result of working hard after suffering a crisis like day zero. So I think once a city or a country overcome the first challenge, you can focus or address the availability of water in informal settlements. So I think there are some cities that are able to do it nowadays, and others, as Buenos Aires, are in another stage in which we have to develop the DMAs system before to to be sure that every slums which are more than 1,500 in the city to solve that problem. Okay?
Brilliant. Thank you. So then, over to you, Henrique. The sort of negative impacts of the solutions that you are mobilizing at such a rapid rate. If you could just share some case studies.
Yeah,
how
absolutely.
You overcome
absolutely.
This.
And one of the things is the manpower, you know. If you see in the research all over the world, one of the, let's say, the jobs that will finish in the next years will be the meter reader, you know, because everything will be automatic. But I think that this is a quite good challenge for the utilities, how they're going to, like Berčon said, you know, how they are going to work around on this and train the people to have another more, let's say, analytics skills, or they can rework. Of course, when, this is my experience in the past, when you visit a water utility and you try to sell some kind of technology, the first thing that they did is invite the guy from IT, from the company, you know, to join you in a nice explanation. And these guys, of course, they know about IT, but they have no clue about the application of these. So there is a downside that people need to improve their skills somehow, but there is an upside that these people could be trained in a more advanced skills based on the technology. And data mining, how they are going to analyze this data, because today I think that everywhere in all kind of applications we are suffering a tsunami of informations that we get for everywhere, you know, but we don't know what to do with this. So before, I didn't have no clue about the quality of the water that I was delivering in front of my customer. I have no clue about the pressure. I don't have no clue about the leakage. But what I'm going to do with this data? So I think that we are migrating the skills of the people from, let's say, more field people to be more analytics. And then, of course, always you're going to have some people on field, but in a smart way, you know, they really want to know. So one of the downsides is this, you know, and one of the downsides that we could consider in the near past was also the cost. But now, more and more, you know, the new technology becomes more accessible for the utilities in terms of price. So these are the main issues that we can find. And there is a big opportunity for the suppliers, the technology suppliers, to support these and adapt also the new ways to contract the people or to hire these kind of people, or the contracts. Now most of the things becomes as a service as well. So what we are also fighting here in the market is sometimes the utility want to buy these new technologies, but the laws or the rules of purchase is not ready as well. So we need to revisit, like I said, the whole ecosystem to adapt to this.
Brilliant. Thank you for that breakdown. It definitely made sense. So a question for Weslley. You sort of mentioned in the Rio de Janeiro area that some areas are very hard to access due to local communities, maybe not being able to deploy or the smart water technologies, or just even, you know, water distribution for the tap. So, you know, that is a risk in itself. How are there ways to overcome this? And does this also provide a data risk, i.e. everything's on IoT, on the internet? And once Weslley's done, if you could come in as well, Henrique, with how you can overcome this, because we're all at risk of our data being breached or being hacked, and now all of this smart metering is on IoT. What do you put in place to make sure that Mr. Joe is not paying 10,000 euros for his water because of some malfunction? So over to you, Weslley.
Milin, I think the solution is exactly the technology. Because in those communities where we cannot access easily and our readers cannot access the meters, and eventually there are some accounts they have due payments that we not can shut off their water connections because it's risky for the operator. So the solution for this is technology. So we are planning to implement smart metering to fully cover all our communities. So there's no need anymore to the reader, the guy who reads the meters, to be inside those communities. And beside the smart readings, implemented a solution to remotely shut off a valve, IoT valve, that remotely shuts off and turn on the water connection. So we have around 10% of all consumed volume of our company has a technology like that. So if your account has a due payment, you have a term to pay the bill, and if you not pay until the time, a automatic command will be sent to your meter to close the valve. So you need to pay the bill until it opens again. And it gets us a better scenario where our operators don't need to face this challenge, which is face-to-face, treat the customer, tell them you're going to turn off their water. So there are significant improvements we perceived with this kind of technology. And then, as we mentioned, all sensors, IoT sensors, put in place on those places where we cannot reach easily give us more visibility of what's happening inside the sector. And regarding the irregularities such as theft, water theft, and things like that, the technology can help us identify those situations. Because when we're talking about smart meter, this was something that we explored deeply because there was a lot of concern about the security of those devices, and then we choose equipment. If there are technical guys here, please correct me, but there are only one-way programmable. You cannot adjust the equipment, the hardware, after it is deployed on field. So the guy, even if he picks the equipment and try to change the configurations and the settings, he will not able to do that. And the opposite happens. Whenever the guy take the equipment off the meter, or try to switch the meter, movement the meter, we receive an alarm telling us that this meter has some kind of irregularity, or if there is a wire connecting the meter to the equipment, if the wire is cut, we have an alarm. If we have a type of water theft in Brazil that is people using equipment to jam the meter. So whenever this happens, we have an alarm. And as well, we have the consumption of this area monitored, and we have the inlet of water monitored. We can make a balance of water and see how much water is being lost in this situation. And whenever the losses increase and there is no leaks in the network, we assume that is maybe increasing water thefts, so we can inspect those connections and identify situations like that. So technology for us is the solution to these kind of situations.
Thank you. That's pretty incredible to where these smart meters can now isolate the water supply, or you get that immediate effect if something's being tampered with. And I guess that also supports the revenue and the loss of water as well with these irregularities. So, Henrique, what do you implement to where, say, cyber attacks? Does that exist in the smart world of water?
Yes, absolutely, absolutely. And I think that the environment that we are working in is very complicated and, let's say, difficult, because if we split the hardware part of the technology, that you are in a very tough conditions of sun, days, night, cold, hot, in water you have a big challenge that is the battery power, that you need this different from the electricity meters that you have all electricity or energy supply for this device. In water you don't have. You need to have really good products with a great technology to save battery, and also you need to be protected for this. But when you start to communicate the data, when you start to get the data, and with these LGPD and so on, the new rules to treat the data of the end suppliers, you need to become more careful about this, because inside the utilities, not everybody should have access on this information, but also you have also attacks from outside that wants to take this powerful data of the profile of your customers, and get this database to use against them. So we are working hard on this. Like Weslley said, in the mechanical meters, you have different ways to make frauds, and people also, believe me, they are trying to make frauds and attack also the electronic meters. As we can have the hackers using the computers, also you have the guys that wants to manage these. And look, for you to have an idea, especially here in Europe, it's very dangerous, because imagine that someone puts something in the water and you can start to drink this water. How big could be the effect of this? That's why implement more technology close to the meter or inside the meter. It's also a protection, for the population, for the citizens, and for not only for the control of the water utility, but also for the citizens. So different attacks, I think that we need to take care of these, especially with the data that we are sharing in different areas.
So from what I understand, in summary, it's cyber attacks, but then also you can use these smart water technologies. For example, if there was a mean guy or woman out there that wanted to add something into the water as backflow, that could monitor that irregularity. Well, that's pretty smart.
Yeah, you could imagine if someone has information that this house do not have a water consumption, it means that nobody's there. So they can into the house and store whatever is inside because nobody's there. So it's very sensitive. We don't stop to think about it, but all these informations are very, very important informations. And people also today with the electronic devices, they can also reprogram the meter, And if you don't use the correct protocols and the correct IP information, all these informations could be around and making a lot of risk for the population.
There are more funny stories, if you can imagine. A man is going for a week to a business trip, and the wife is going to her mother, but somebody is consuming water in the house. Not one, two.
The moral of the story. Well, I'm truly getting a real sense of how smart this water can be, if your wife or your husband's cheating on you, but then also the positives are really outlaying sort of the negative elements of the cybersecurity, etc. And if you could share, and we'll start with yourself, Matjaž, the positives, energy, the costs of treating water, with having these smart solutions, with pressure management, leak detection. What does that mean to the end user? Does that mean lower bills or cleaner water, or, hey, you've got community engagement and you're on the smart system and that's it? What's the value of to the end consumer?
Always, and on the first place is the quality of water and reliability for customers. This is we cannot avoid this. Normally, we as a responsible utility management, we take care also about other costs, like electricity increased in past few years to the, let's say, to the sky. Now, fortunately, again, fold. Normally, costs of all stuff increased in past 5 years for 20-25%. So all those let's say inputs we have to consider when we calculate the final price for the customers. At that moment, I'm visiting 7 municipalities, 7 municipal councils, and I'm trying to explain the councillors why we are increasing the price of the water. But still, we are the cheapest in Slovenia. So our water is, for example, 50 cents per 1 cubic meter for 10,000 liters. The cheapest water in supermarket, 1 liter, is €1. So we are 20,000 times cheaper than supermarket, than something what we have here. So yes, we have to be responsible also regarding costs. And normally, 15 years ago, we started with a project of leakage reducement, and we reduce leakage from more than 50% to nowadays 30%, which is good result for Slovenia. Maybe my colleagues, they don't say it in the public, but still in Slovenia we are between 40-50 in average. We are at that moment on 30 after investing $250,000 per year last 10 years. And of course, normally also our municipalities, they invested, I think in past 10 years, they invested 20 million euros in new infrastructure. For example, you all know Krvavec ski slope, from Krvavec to Kranj, to Vodice, to Komenda, to Šenčur, is completely new water pipe for 10 million euros. Only this one. After 50 years, it is completely new. Almost 10 years ago, it was another one. As I said, at least 2 million euros per year only for our system, but we are not the biggest, and we are only, let's say, 5% of Slovenia.
Fantastic, thank you. And over to you, Gonzalo. You know, your work, the fantastic work that you've been doing over the years in public health, smart water, public health. Give me just a quick rundown of a case study of how this is implemented and helped communities.
And do you want an example or
just an
idea?
example that a real sort of live case study that you could just provide a quick rundown of how this has supported communities?
Well, I think it is very interesting, insightful for us to discuss what is happening with illegal drugs, for instance. New technologies allow us to detect when the consumption of cocaine, for instance, is increasing in one neighborhood, mainly in informal settlement, when the narco traffic is installed stronger than ever. So we implement or carry out project of detecting cocaine, metabolism of cocaine in some basin, for instance, and we can prevent the young people from get a disease, to be in jail due to the consumption of illegal drugs. This is an example in which new technologies help us as a community to avoid problems.
Wow, I really did not think that today's conversation in regards to smart waters and the way it's being distributed could actually help the combat of illicit drugs, narco traffickers as well, but then also providing wholesome, clean drinking water at lower cost, lower rates of leaks and energy for the carbon footprint as well. Unfortunately, I'm going to have to end this panel because we've gone over time, but absolutely interesting that how smart waters are definitely developing the way we consume water, monitor water, for wholesome, clean water. And I just wanted to say that the water in Kranj is better than some of the global brands of bottled water. So if you do have an opportunity, head over to Kranj. They've got amazing public water features that you can actually drink from, and I highly recommend it. Thank you, gentlemen. This has been fantastic.
Thank you, Milin.
Thank you.
Thank you, Brazil, as well.
Thank you.